Hi everyone, my name is Sukwon from UNC Chapel Hill, and today I would like to introduce our work, Oldie but Goodie, Re-illuminating label propagation on graphs with partially observed features. This is a collaborative work with KAIST, AIST, and Institute of Science Tokyo. This work focuses on missing features, especially in the graph data. Nowadays, we observe diverse type of graph structure data as below. However, one key inductive bias when dealing with such graph data is the assumption that each node has fully observed features, which is often not the case in real-world scenarios due to diverse reasons such as privacy concerns, etc. As a case study, we varied the observed feature rates from 0 to 1 on the size-zero graph data, and we compare with the recent GNN-based models and structure-based models and its hybrid model, and then we observed as more features are being available, GNN-based models outperform the baselines. However, when the observed rates fall below 0.1, structure-based models outperform the GNNs. So as the observed rates vary in real-world cases, it becomes tricky to decide which model to use at each point. On the one hand, feature propagation is now being widely used in the graph domain to impute the missing features. However, solely managing such features is not sufficient for the graph data, as we have seen in the previous slides. Thus, to further incorporate the structure and the label information, we revisit a classic method, label propagation on Oldie, which shares the same philosophy as the feature propagation but operates in the label space by leveraging the graph structure. Now, called by Goodie, over-architecture is shown below. We have three-stage design. So at stage 1, each branch produces its own embeddings from label space and also the feature space by using the GNN decoder and GNN encoder. And then moving on to stage 2, we want to differentiate the embeddings from each branch. So we conduct a structure, feature attention. And at the stage 3, thanks to the labels that has been observed and obtained from the label propagation branch, we further leverage the pseudo labels by differentiating the significance of each labels by using new pseudo label contrastive learning. So as an experiment, we conducted node classification on 7 datasets with the diverse observed rates, and then this red dashed star, which is the Goodie's performance, we observed Goodie is outperforming in most cases to those of these GNN-based and structure-based and its hybrid models. And this is the performance of the node classification and missing rate 0.9999. So we observe Goodie is performing well compared to those baselines. And even in the link prediction, Goodie is outperforming those baselines. So as a conclusion, we started from the problem with the missing features in graph, and we observed GNNs perform worse than structure models at low observed rates. So as a solution, we revisited label propagation, which is Oldie but now called as Goodie. However, the challenges were like how to deal with the missing rates. So we designed some attention over 2 branches, and also given the labels different reliability, we used a pseudo label weighting, and then we performed evaluated Goodie under diverse missing feature scenarios. Thanks for hearing, and feel free to drop me an email if you have any concerns. Thank you.